Hello students, today I am going to discuss the easy way to draw the left ventricular pressure change during cardiac cycle with its explanation or interpretation. Before drawing, we have to remember that the ventricular systole consists of isovolumetric contraction phase, rapid ejection and slow ejection. The isovolumetric contraction phase means that the volume remains same but there is still contraction. The ventricular diastole consists of protodiastole phase, isovolumetric relaxation, fast rapid filling, slow filling or diastasis, and the last rapid filling. Again, the isovolumetric relaxation phase means that the volume remains same but there is still relaxation. Before drawing the left ventricular pressure change during cardiac cycle, we have to draw 11 lines. By maintaining proper gap between third and fourth line, fifth and sixth line, sixth and seventh line, 7 and 8 line, and 9 and 10 line. The first line is divided into 7 regions by drawing 7 lines to indicate the blood pressure from 0 to 120 mm of mercury pressure. The second and third line indicate the isovolumetric contraction phase. The gap between the third and fourth line indicates the ejection phase, which consists of rapid ejection and slow ejection. In this picture, we do not figure the protodiastolic phase. We will comment from the isovolumetric relaxation phase. So, the fourth and fifth line indicates the isovolumetric relaxation phase. The column next to it indicates the rapid inflow, then diastasis, and then atrial systole. This is the total cardiac cycle, that means ventricular systole and ventricular diastole. After the atrial systole, again comes the ventricular systole, that means isovolumetric contraction phase. After that, it is ejection phase and it is isovolumetric relaxation phase. We have to remember 4 markings. First is 120 mm mercury pressure, second is 80 mm mercury pressure, third is about 5 mm mercury pressure, and fourth is about 0 mm mercury pressure. Before the isovolumetric contraction phase, the aortic valve remains closed, and at the beginning of the isovolumetric contraction phase, the atrioventricular valve is closed by the atrial blood pressure. So the ventricle becomes a closed cavity and its volume remains same. That means isovolumic. But there is still contraction. So the phase is called isovolumetric contraction phase. As the ventricle contracts in a closed cavity, the pressure of the left ventricle sharply rises from 0 to 80 mm mercury, and this 80 mm mercury pressure pushes the aortic valve and causes the aortic valve opened. In the rapid ejection phase, the blood from the left ventricle passes to the aortic valve into the aorta. But there is still contraction of the left ventricle, and the force of contraction is more than the amount of ejected blood. So the blood pressure in the left ventricle rises and it reaches about 120 mm mercury. Then in the slow ejection phase, blood still passes through the open aortic valve into the aorta, and here the blood pressure of the left ventricle decreases and it is about 80 millimeter of mercury. The blood in the aorta pushes back the aortic valve and causes is closed. So again, the left ventricle becomes a closed cavity and the volume remains unchanged, that is isovolumic, and here the ventricle begins to relax. So the ventricle relaxes in a closed cavity, and during this isovolumic relaxation phase, blood pressure in the left ventricle sharply decreases and it is about 5 millimeter of mercury. Now, the pressure in the atria causes the atrioventricular valve open and blood passes from the atria to the ventricle through the open atrioventricular valve, and the first phase causes the rapid inflow. But as the relaxation is more, so the blood pressure in the left ventricle begins to decrease and it is going to about 0 millimeter of mercury pressure. In the slow filling phase or diastasis, the blood passes through the open atrioventricular valve from the atria to the ventricle, and here the pressure remains unchanged, that means close to 0 millimeter of mercury. And in the last phase, that means in the atrial systole, blood pushes from the atria through the open atrioventricular valve into the ventricle, and this causes the pressure in the ventricle to rise. So this is the pressure change in the left ventricle during the cardiac cycle. After that, the cycle repeats, and here again the atrioventricular valve closes by the left ventricular pressure, and the left ventricle becomes the isovolumetric phase by isovolumetric, and here the contraction begins. Again the pressure sharply rises about to 80 millimeter of mercury. Then the aortic valve opens and blood is ejected from the left ventricle to the aorta through the open aortic valve, and in the rapid ejection phase, as force of contraction is greater than the amount of ejected blood, the pressure in the left ventricle rises to about 120 millimeter of mercury, and in the slow ejection phase, the pressure of the left ventricle decreases to again about 80 millimeter of mercury, and here the again aortic valve closed and the ventricle becomes a isovolumetric compartment and the ventricles begins to relax, so the pressure begins to fall, and this is about to 5 millimeter of mercury. Then in the next is again the rapid inflow, the cycle repeats. So this is all about the left ventricular pressure change during cardiac cycle, and it is the easy way to draw the figure. In the next session, we will discuss with another topics.